Welcome to the full solutions to the practice questions from the first lesson of cross products in the vector series. In the first question, we're asked to show that when we take the cross products of unit vectors k and I, we get a unit vector j. So unit vector k is equal to, it has components 0, 0, 1, and unit vector I has components 1, 0, 0. So when we take the cross products, then what happens is we get unit vector I, j, and k. For unit vector k, we have 0, 0, 1, and for unit vector I, we have 1, 0, 0. And to get the answer to this, we're going to have unit vector I, and we'll cross out the top row and the column that has I in it, and we will do a cross multiplication of 0 times 0 and subtract it by 0 times 1. So it's going to be 0 times 0 minus 1 times 0, or 0 times 1. And that's going to give me, I'll just do this section for now, 0 minus 0, which is just 0. After this, we're going to use minus unit vector j. I'll use blue for this. Now we are going to cross the top row as before in the column that has j in it, and we are going to cross multiply 0 times 0 here and subtract it by 1 times 1. So it will be 0 times 0 minus 1 times 1. And then we're going to have plus k. And now we will cross the top and the column that has k in it. And we will do, here we will do these two multiplied by each other minus these two multiplied by each other. So that will give me 0 times 0 minus 0 times 1. So for the j component, so I is already completed. For j component, I'm going to have 0 minus 1. And for k, I am going to have 0 minus 0, which is 0. This term goes away, this term goes away, so I will have negative j multiplied by negative 1, which is positive unit vector j as my final answer. For the next question, we're asked to determine the unit vector perpendicular to vectors a and b. Well, by definition, a cross product of two vectors will result in a vector that is perpendicular to both of those vectors. So we can do that to find the vector, and then we will divide it by the magnitude of the vector in order to find the unit vector. So the first step to these is to find the cross product of the two vectors, and that's going to equal to I, j, k. For vector A, my components are negative 3, 0, and 1, and for vector B, there's 0, negative 1, and 2. Now I will write this as vector I, and that means I will have to cross out these two and multiply. I'm going to multiply 0 times positive 2, and I'm going to subtract that by 1 times negative 1, and the next one is going to be minus j, and I am going to cross out j, and I am going to use this times this minus this times this, so that will become negative 3 times 2 minus 1 times 0, and then I'm going to have plus k, and for the k, I am going to block the k column, and I am going to multiply this times this and subtract it by this times this. So that will become -3 times -1 plus or minus 0 times 0. For my I component, I will get 0, negative and negative multiply to a positive, and then I have minus j. I have -6 minus 0, which is just -6, and I have positive k, and I have -3 times -1 is +3, minus 0 is just 3. So the x, y, and z component of my vectors here for the cross products of a and b. For the x component, I get 1. For the y component, I get -6 times -1, which is +6. And for the k component, I just get 3. Now I have found the vector that is perpendicular to vectors a and b. I need to find the unit vector. And to find the unit vector, I have to take the vectors a and b, their cross product, and I have to divide it by their magnitude, or the magnitude of the cross product. So the magnitude of A cross B, I will do it here, will be the root of their x component squared plus y component squared plus the z component squared, which is 1 plus 36 plus 9, which is equal to root 46. So my final answer here is going to be 1 over root 46 multiplied by my vector 1, 6, 3. And we can rationalize this. I do like to rationalize my final answer. So I'm going to multiply whenever we have 1 over root 46. We multiply it by root 46 divided by root 46. And the denominators will become 46 and the numerator becomes root 46. And again, we rationalize because we don't want to have a root at the denominator, and that's the standard form for surds and radicals. So my final answer that then becomes root 46 over 46 multiplied by vector 1, 6, and 3. And I will highlight this as well. For our last question, we got Robo who exerts a force on a nut at delta D, distance delta D, from the center of the mass, and we want to determine the magnitude of the resultant torque. We know that by definition, torque is equal to the cross product of force and displacement, and then we would have to find the magnitude of that afterwards. So let's find the cross product. First, to find the cross product, we're going to take vectors I, j, and k. For force, my components are 4, 5, and 3, -4. And my delta D's components are 0, -4, and 3. So then I will have I. For I will cross out the top row and the I column, and I will use 5 times 3 minus 3 times -4. And for my j component, which is negative, I am going to block off the top row and the j column, and I am going to multiply -4 by 3 and subtract it by 0 times 3. And for my k component here, I will cross out the top row and the k column, and I will multiply -4 by -4 and subtract it by 0 times 5. I will then simplify. I will get 15. Negative times a negative is positive, so I will get 12 here minus j. I will get -4 times 3 is -12 minus 0 plus k. -4 times -4 is 16 minus 0. And this will give me 27 times vector I minus and minus here, negative and negative make it positive, 12 times unit vector j, and for my vector k, I get plus 16 in the unit vector direction of z. Now the vector that we got here, and I forgot to put the vector sign, is the vector, and we want to find the magnitude. So the magnitude of the torque is going to be the root of the x component squared plus the y component squared plus the z component squared. And we will end up getting a root of 1129, and my unit for this is Newton meters. And I can leave it in an exact form like this, or I can do it as approximately 33.6 Newton meters in 3 significant figures. I hope that this video was helpful in giving you some practice with the basics of cross products. Thank you for watching.